Application Engineering, National Institute of Technology, Karnataka, Surathkal from 2013. Dr. Shyam was visiting professor at University of Pavia, Italy, and he was also a visiting fellow at Tokyo Institute of Technology, Tokyo, Japan. He has more than 19 years of teaching and research experience. He has supervised 6 PhD students, and currently 4 PhD students are working under his supervision in the area of medical image processing, satellite image processing, Internet of Things, and cybersecurity. Dr. Sham has completed 4 R&D projects funded by SERP, DST, ISRO, and currently 2 R&D projects funded by Google and ISRO are being carried out. Dr. Shamblal is also CEO, Director, and founder of AI Quantum Smart Solution Private Limited, NITK Step, Surathkal, India. So he is consultant of Starfleet Ventures, Canada. Dr. Sham has published around 100 research papers in the area of artificial intelligence, machine learning, and deep learning with applications in medical image processing and satellite image processing in various national and international journals and conferences. He has received Early Career Research Award in 2017 from SERP, Department of Science and Technology, Government of India, and Young Faculty Research Fellowship in the year 2019 from Digital India Innovations, Government of India. Dr. Sham has also filed one Indian patent. So he has delivered more than 80 invited talks and expert lectures in the area of artificial intelligence, machine learning, and deep learning with various applications in the field of science, engineering, and technology. So he is been guest editor of IJSISC, Inter Science Publisher, editor member of Open Access Journal of Biomedical Engineering and its application, Lupin Publishers USA. And Dr. Sham is also holding vice chair position IEEE Geoscience and Remote Sensing Bangalore session since 2021. So he is senior member of IEEE, life member of ISTE New Delhi, life member of IAENG Hong Kong, life member of IACSIT Singapore. Dr. Sham research area of interest include artificial intelligence, machine learning, deep learning, and optimization algorithm with applications in radiology image processing, histopathology image processing, satellite image processing, IoT and cybersecurity, and manufacturing industry. So I request Dr. Shamla sir to take over. Thank you, sir.
Thank you, Mr. Raju. Okay, so good morning, one and all present in this meet. So I will be talking on basically introduction and applications of machine learning and deep learning for remote sensing. And basically two aspects, giving the brief introduction about AIMLDL, and then what are the project or what are the research you can do in the field of remote sensing using machine learning and deep learning algorithms. So that is my focus. So my outline includes, as here, we'll be talking very bit introductions, neural networks, deep learning and deep learning architectures, and for the various application in the remote sensing, then applications of the deep learning architecture in another field of engineering and technologies, and there will be some open source data set for the deep learning models, and what are the tools used for the annotation of the deep learning, and finally that what are the research conducted in a remote sensing field at an ITK. You will get some glimpses about that also. So before going to, jump into the topics, core topics, let me give you, if you are the beginner, then and wanted to work on in the area of deep learning, which we also called as a convolutional neural networks. So you should have two broad knowledge. One is a domain technical knowledge, which includes linear algebra, probability, statics, fundamental of image processing, fundamental of computer vision, and a strong foundation on artificial neural networks, and some core subject, which includes remote sensing as a fundamental of remote sensing, and many concepts which, so as a remote sensing as a core subject, which already talked about Dr. Nagajyoti from this row. He has already talked about the fundamental of remote sensing and what are the various application or what the projects or the research you can conduct in the field of remote sensing by using recent algorithms, I'd say AI, ML, DL steps. Likewise, your other field of the core technical knowledge, you should also go through that. If you are the broader domain, 5G, beyond 5G, IoT, cybersecurity, DSP, mechanical core subject, electrical, civil, metallurgy, etc. Then the second and again the foremost skill required, because from that first the knowledge you will get idea what is your research problem, what are the problem which you want to solve it, right? Then how to solve it the problem or the project, for that you need a software skill. So in a software skill, as a Python is one such sort in a coding language in academia as well as industry. The reason is that because it's open source, which anyone can use is for doing the project work. So you should have the deep Python coding knowledge, NumPy, SciPy, Panda library, OpenCV, and also you should require the fundamental or the application oriented knowledge of scikit library. Whenever you want to quantify any algorithms or deep learning models, then you need to use scikit library for computing various quality matrices. Or if you are not, if you do not want to use this library, you can write the code from the scratch also for the all metric functions. Then as a last is the deep learning framework. So there are various framework in the past since 2015. So it started from the Keras framework, TensorFlow, and then PyTorch. These three are the very important and popular framework for the academia as well as the industry for building the models for various application in the field of remote sensing and other engineering and technologies field also. So the more focus is mine emphasizes why you need to go for the Python is because one thing you can do the project in the remote sensing. Also the Python having other advantage where you can do some kind of even the if you want to build your personal website, you can use Python. Even you can use Python as app development. You can be a Python API developer. You can use Python for helping others codes. You can create even the games using Python, and you can write software to computer programming that is student, even data visualization using Python you can do. Even the, as I told you, for AI development or say for AI ML model development using Python you can do. You can make the task automation using Python. And I mean, a lot of the things you can do with the open source Python. And Python is actually the third preferred language as compared to the C and Java. So last 2 years, even the Python was number one as far as the usage of the language is concerned. That where the C and Java was in the other places. So moving ahead as a bit introductions about the neural network. So the first neural network that was proposed by uh, Baron, Maklo and Pitts in 1944 for solving arithmetic and some numeric problems for the digital and then arithmetic problem solving. So they were the pioneer, I would say, and they were got the Nobel Prize also for their contribution, and with the help of very limited resources, they were able to build a neural network and able to solve the that arithmetic and as the digital logic problems. For example, additions, multiplications, they were easily do with the help of neural networks. And during the last 10 years, you will see that you are already seeing that a lot of best performing artificial intelligence has been already deployed for various application. One such application is called as a speech recognition on the smartphone or the Google, that even the Google latest automatic translator, they are using that AI based translator. And if in fact, whenever you want to go any services work by round the clock. So for that case, you need to AI based. So AI based in the sense that neural network based, the algorithms or development which you are going, that will work the 24 by 7. So that one such example is, for example, chat booth. Chat booth is also one's best example of AI based system which will work 24 by 7 for your maybe your company or any specific enterprises. So if there you can ask developer for chatbot for your company also. Then, as I told you already, you have some idea about image processing, computer vision. So, what are the tasks which you can be do in case of computer vision, right? So, in computer vision, as I told you that already that I mean the tremendous or say for lot many the algorithm systems we has been have been developed for various application in a healthcare, in the manufacturing industry, even this, if you recall, in Corona time, the various that is, I mean, the robotics was developed for the, I mean, to make the avoid the that distancing, maintain that social distance. Even the hospital, that robot was installed for the initial screening of the COVID symptom. Lot more industry also manufacturing has been developed, but uh, majorly, if you look at the what are the tasks involved in the computer vision, which is based on the two kind of things. Either you have single object task, either you may have the multiple object task. So in single object task, you will see that we have that called a simple classification task. So classification task, if you look at that classification cat and say for this dog and cat classification task is very simple task in the sense that here how you can understand in terms of the and more detail. Suppose you have image, and image is nothing here that is read by pixels. So all the pixels of this image that will be belonging to one class in the sense that all the image of the pixels is assigned to be either cat or maybe a dog, right? So that is called very simple way. All the pixels belongs to the one class, single class. So this is called classification, cat and dog classification. Or we have, say, for example, this maybe that earthquake affected images are there, buildings. So affected, damaged and non-damaged images in remote sensing, or you have the medical field, cancerous, non-cancerous. So just you get idea. Basically, the image is what actually it's like whether it's a cat image or it's a dog image, right? You get idea. But if you wanted to find out where exactly object is located in the image, then you need to do one more operation called localization. So classification and localization is used for the object detection task. For example, here you can say that this here we get idea this image belongs to cat, but where exactly cat is present in the image, that will not give idea about the classification. So you need to go for classification. So for this localization, we normally use called the boundary box. So you can see here with the red color boundary box. So we can localize the that cat. So cat you can see here easily in the boxes. The cat can be easily detected that, right? So this is related to a single object task. Likewise, you can do even the SAR data. You can use SIP detection. SIP detection is also that will be called that object detections, right? From the various deep learning algorithm could be used for the SIP detections also, right? Which is very important, or maybe Fisher boat, right? That could be used also. Then in the case of multiple object task, right, we have there are two type the task we can do. Either we can do again object detection or we can do the segmentation task. In object detection, here you can see that we have three objects: cat, dog, and this duck. So for the object detection in for multiple object data set, we can use I mean the different colors for detecting the object by boundary box. So what we are doing, we are assigning different boundary boxes. So you can see here there is a red boundary box belongs to the cat object, and the blue boundary box is belongs to the dog object, and then the green boundary box is belongs to the duck here, right? So here easily you can detect the multiple objects using the algorithm, computer vision algorithms. But what is the problem of this object detection here? You can see when we have two cats, right? So there is a overlapping here, right? This region is overlapping. So if you do the some kind of algorithms, this maybe sometime may not be good, right? So what you can do, instead of using object detection algorithms, we can use some other concept called the instant segmentation. But instant segmentation, before that, let me talk about what is the semantic segmentation. So we have seen the classification, right? What we did in classification, in the technical words, all the pixels of the image is belong to one class, right? Now that is called classification. But once we come to the segmentation, then, right, instead of all the pixels belong to one class, what we'll do, we can assign the set of pixels. Set of pixels belong to the, I mean, the classes, right? For example, here, if you look at the specific definition is the task of assigning class to every pixel in a given image. In the sense that the whatever the image is there, so all intensity value or the pixel value of the image is not belongs to the one class. So the intensity value, some set of pixels belong to the one class of the object, and the other set of pixels belong to the other set of object, and next set of the pixel belong to the other object, right? So this is what will possible. Maybe we can do binary segmentation, or we can do multi-class semantic segmentation, right? So if it is a binary segmentation, task is very easy, right? Because you have to classify the background and foreground, right? But if you have the multi-class, then the designing of the deep learning algorithm bit, you need to be more challenging, right? So here you can understand the multi-class semantic segmentation very clearly over here. So we have this is the input image, which is given to the DL algorithm, and we are predicting this image, right? So if you see the input image, what we have, this is called the person who is driving the bicycle, and then bicycle is other object. Person is a first object, bicycle is second object, and third the object we call class called the background, right? So how we can do the object detections right here? So person is one color assigned. So that means the intensity value set of pixels which will be here will be representing the, I mean, the persons, right? So that we will be assigning that. Of course, we require the ground truth data. So for predicting this output, but what you can understand, so like this person one, so that brown color is belongs to the person object, and the green color is belongs to the bicycle object, and the black colors belongs to the background object, right? So this is what we call as a multi-class semantic segmentation, right? Now, and if you see binary segmentation, very simple. So you can see we have the person and the background. So person is assigned one color, which is called binary semantic segmentation, and then background is black here, right? So what is the problem of semantic segmentation is that the major problem of the semantic segmentation is that they are not able to algorithm to give instances of the object. Instances of the object in the sense that the algorithm is not able to tell which one is a person one, person two, and person three, right? Which is driving the bicycle. Similarly, which one is one, bicycle two, bicycle three, right? So this major that problem or the drawback is solved by the instant segmentation concept. So in instant segmentation concept, you can see that the algorithm is powerful, but it's complex as compared to the semantic segmentation algorithm. So you can see that same example right here. So binary segmentation, and then that instant semantic segmentation, right? So you can see that here the algorithm is giving the boundary here to person 1, person 2, person 3, person 4, and person 5. That means the instant segmentation algorithm is able to assign instances of to each object with the different colors. So person 1 different color, person 2 green, person 3 different, person 4 blue, person like purple color, here 5, right? So that is what. So that is why here there was a problem in a object segmentation. What the two frames are the this that rectangular box that is overlapping. So, but if you see that instant segmentation, the algorithm is able to do nice job as compared to the normal object detection task. So you can see the cat 1, cat 2 easily that instances of the boundaries assigned right now. And you can easily see this is perfectly cat 1, cat 2, and then we have here the dog, and which is blue boundary bar. I mean the given the instances, and then duck here. Right? So I hope you likewise you can go for 4 classes, 5 classes, 10 classes, depending on your data set that will be there. So instant segmentation, there is a lot more scope for doing good research on the remote sensing data. If you're interested, you can explore. And of course, you can, lot of is always scope on also multi-class semantic segmentation also from the slide data. I hope you got idea. Now, moving ahead bit further, here you can say there are, I mean, 3 big words always will be coming called artificial intelligence, machine learning, and deep learning. Let us bit understand each terminology here, right? So artificial intelligence is a branch of computer science, and the main objective of artificial intelligence is to build a smart machine which is capable of performing a task which exactly human intelligence requires. I hope it's clear. It is a branch of computer science, and the main objective of this artificial intelligence is to build a smart machine, the machine which is capable of performing a task which exactly human intelligence requires. In the sense that, so whatever the task done by the human, for example, robotic surgery or in manufacturing, the many thing like say for carpentry or many things or a smithing thing, right? Whichever the task done by the, I mean that this operator, mechanical engineers or these doctors, so can be replaced, can be done by the, that will be the AI based system, right? Then and this AI is a broader, right? It's like big umbrella. If you see here, this is a circle, right? So AI is on the top, right? So this AI is basically having the is basically due to the advancement in the machine learning and deep learning, the AI is used widely in the tech industry as well as in the academy also for the teaching learning. That's why you will see that the AI City has introduced BTech in AI, BTech in AI ML, BTech in AI data science. So lot more many the UC program in undergraduate level has been introduced in the field of AI also. Then if you look at, and this is the very beautiful, very good YouTube lectures you can just explore after that. Here it will be see that how AI is powerful for the, I mean that making the robotics for doing many tasks which normally will be done by the humans. So human task, the work which was done by the human is replaced by the machine, right? And then coming to machine learning, in a simple word, machine learning, if you want to define, machine learning is the process of teaching a computer system how to make accurate predictions when we fed input data. Very simple word. And of course, it will be learned that having the ability to learn without being expertly programmed, in the sense that we have to just write a code and then with with a set of training data, and then we can, once learning algorithm is learned, you whenever you give the any test data, the algorithm is able to give a that correct output, right? So you can match with the original or ground truth data. Third is deep learning. So again, machine learning is the subset of the artificial intelligence. And then third is called deep learning. So deep learning is basically is a now everywhere the word is a deep learning, deep learning right now. So but the deep learning is a subset of machine learning in which the artificial neural networks adopt and learn from the vast amount of data, in the sense that if you wanted to apply deep learning algorithm, first of all, you should require the large amount of data. If you have the large amount of data, then the performance of the deep learning will be much superior than the any traditional machine learning algorithms, right? Moving ahead, this is a big picture of the machine learning algorithm classifications, which you can see that we have a supervised uh, learning algorithms. In a supervised learning algorithms, broadly, you can do two kind of tasks. You can do regression. Regression in the sense that regression means we want the model or the algorithm always give some output, right? So that is what a simpler way, right? And a lot of the task, if you see that weather forecasting, market forecasting, share their price forecasting, even the estimating life expectation, and even the population growth predictions, even the lot more in image processing, remote sensing. I'll be giving the with examples later on, you'll understand. And then you can do classification. Classification, you can do binary classification, you can do multi-classification, can be used for the medical, can be used for wireless communication. I mean, whatever the field nowadays, you see agriculture, remote sensing, right? Urbans, you can use a classification task, right? So you can do that, right? Then third is called as a supervised learning. So in supervised learning algorithms, right, we need a label data. Without the label data, the algorithm will not be work, right? That is what one such algorithm. But you can also go for the transfer learning approach. We will explore later. Then you can go for the other kind of algorithms called unsupervised learning algorithms. Unsupervised learning algorithms are divided into two broadly type. One called the dimension reductions. In a dimension reduction techniques, there are various algorithms you can explore and see that which could be used for feature elimination, structure recovery, meaningful compression, big data visualization, which will be used for the dimension reduction. Even the PCA is one such example that can be also used for the dimension reduction, but you can also use other kind of the method for dimension reduction also. Likewise, if they have clustering algorithms, for example, k-mean clustering algorithms, which can be used for the various application, customer segmentation, recommendation system, and target mark setting, etc. So all these things are basically the unsupervised learning algorithm. In the deep learning field, if you look at that, the generative adverse network, we probably call GAN models, which also we call as a unsupervised algorithms, right? And third category is called the reinforcement algorithms. Reinforcement learning is broadly used started in the gaming applications, but now also use a robot navigation in autonomous vehicle and many real-time decision, and then that could be used as reinforcement reinforced learning algorithms also. So broadly, if you see that learning algorithms are three types: supervised learning algorithms, machine learning algorithms, unsupervised machine learning algorithms, reinforcement machine learning algorithms. These are the examples. If as a beginner, you can think as a first task, which as I told you, we should require the label data to train the object, in the sense that to train the algorithms, we need the ground truth data. One such most popular data set and the task called the handwritten digit classification or recognition with the MNIST data set, which was introduced by the Lee Q et al. In 1998 for the whenever they did their task for the, I mean, they were the first who built a linear 5 model for the as a first senior architecture for the simple task. Later on, that big research or breakthrough research happened in the field by the introduction of or by the invention of the Lexington architecture for image recognition task on the image and data set. So broadly, you have the task like here. I mean, if you give the input handwritten input image, which are the digit, you will be able to predict the class of the digit whether from 0 to 9. So input image and target will be always be a digit class, right? 0 to 9 could be any one. And this data set having the 70,000 images of handwritten labeled is also by human also there. You can divide the 60,000 data images for the training and the 10,000 could be used for the testing also. Or training set you can split into 50,000 training and you can say for 10,000 for the validation also. So training, testing and the validations right now. So validation is the part of training. You can split that. So test data is basically completely unseen data by the algorithm supervised that learning algorithms, right? So this was a paper, right, which I was showing that, right, by Lee Kuhn et al. In 1998 for the object recognition task. Then unsupervised learning, we do not require the ground truth. We do not require the label. So instead of that, the data will be classified based on the looking interesting pattern in the data. For example, here we have input raw data, which is unlabeled. So the data having the two the categories or the two classes, cat and object the images. So by using the some interpretation and applying the algorithms, doing some kind of the processing, write a code, how going to be do classification, right? That output layers. I mean this like say for 0 and 1 classes. So maybe 0 belongs to the cat and 1 belongs to say for dog, right? So you can do cat and dog classification by using unsupervised learning algorithms. Like which other example you can see unsupervised algorithms. We have raw data algorithms. So here there are three type of data. You can say triangle, then cube, and then circle. So by the algorithm, unsupervised algorithm, you'll be able to classify the that triangle, cube, and then circular kind of the objects, right? And then these are the, as I told you, like GAN is also unsupervised that algorithms, which are more powerful. You can think about, you can also use a lot of more resources going on. For example, this input image can be transferred to like this photo. So texture keepings remain, the color will change here right now. So the texture of this image monet is same, but if you look at the photo, it changed completely right now. Like here, and then bottom here, the photo is this. So with color has been changed, but the textural properties remain same here, right? Likewise, zebra to horse and horse to zebra, you can also do that. So this is what the cyclic GAN is one such important model, which you can explore as a unsupervised deep learning algorithms for the various tasks. Moving ahead, bit introduction about the neural network, artificial as a neural networks. So neural networks are classified into three types: artificial neural networks, convolutional neural networks, that is called CNN, and the recurrent neural networks. So this is as a started in 1960s, and this was started as in 1998 when the Kuhn et al. Introduced the Linear 5 architecture, and this was also started back this after 98. This was mainly as first to use for the like these are the traditional machine learning algorithm. I would say this is the like say for that deep learning architecture you can call CNN, and this mainly applications broadly used in the basically the NLP, that is called natural language processing, and also in remote sensing, more specific use for time series data analysis. So even for time series data analysis, you can do CNN. But CNN broadly, if you say either you can use 1D CNN, either you can use 2D CNN, either you can use the 3D CNN, right? So for time series data, remote sensing data, you can also use 1D CNN algorithms, right, or architecture. So let us discuss very brief what is the neural networks. So neural network, if you want to define, very simple, it is a network of connected artificial neuron. What artificial neuron is nothing kind of one node. One node is looks like this in a mathematical in the as a structure looks like this here, right? If you see here, we have inputs which give an x1, x2, xn. Then each input is multiplied with a weight which is called W1, x2 multiplied W2, and xn input multiplied by Wn. So this input is nothing. These are the features. And these features are always we have to give in the form of a vector, column vector, right? So all the input in a column vector we have will be there in your data. So we'll be multiplying in the form of as a bit, which is called W1, W2. And then after that, we need to sum it here, right? Sigma, right? And there's one more input coming called the bias. And then after this called the activation functions, right? And then finally we'll get the neuron or the node output will be calling y1 hat. So as a one single neuron, if we how we write the mathematical expression of a single neuron is like here. Y1 hat, that mathematical expression of single neuron is equal to f. F is a function. What is the function? We call as a broadly activation functions, but it is we call as a non-linear activation functions, so non-linearity behavior. And in we see big bracket is called B, which is bias here as input, plus sum of I goes from xi wi. I goes to depend on the input feature I to say for 1 to n, right? So xi is a column beta features, wi is a bit, right? So we'll sum it here and then here the bias. So now question arises, why we are using bias? So bias is used to adjust the output of a network in a broader sense. More specific here, the bias is used to adjust output of this particular neuron, right? So if we have 100 neurons, so each neurons are adjusting their outputs, right? So that's why very simple way, new bias is used to adjust that output of a node or the neuron, right? And the value of bias, it could be a positive, it could be a negative, it could be zero, it could be any random variable, random value also. So I mean this designer can decide or user can decide that, right? And one more things, just take away from you, the weights and the bias are the trainable parameter in the neural network, right? So this has to be updated. Once we give some random values, some random parameter values, after the training the networks, the weights and the bias of the neural network will get optimal. Optimal in the sense that why we are calling optimal is the best weight and then best bias value, which will be giving the best predicted output of a model, right?
Hello.
And the question arises why we are using the nonlinear activation functions, right? There are two kind of activations. One is a linear activation and nonlinear activations. Both are having the importance in terms of the neural networks instead of the deep learning, right? But why we will be using always the neural network nonlinear activation function in the inside the neural network. So there are three key property or the feature of any activations. Function should be a nonlinear when we are using this. Second, should be a continuously differentiable. Third, the function should be a fixed range. There are the three key properties of any activations functions, right? I'll repeat, nonlinear. Two, continuously differentiable. Three, should have the fixed range. And there are number of the activations which are used in the deep learning. Dr. Jenny Rajan will be exploring tomorrow. I'll not go for the more details. That is sigmoid activation function, tanh activation function, ReLU activation function. There are three popular. Sigmoid is the range 0 to between 0 to that 1. And tanh activation range from -1 to 1. And then ReLU activation function, the range will be from that will be 0 to infinity. More details will be talked by the tomorrow. I'm not going for that. But the answer is still left, right? Why we are using non-linear activation? We are using nonlinear activation function in the neural network. Reason is that because if we are using the nonlinear activation functions that give a power to neural network to learn a very complex data, whatever the problem or the data, whatever you want to do project which is available around you, the data is a complex. The problem is complex. So to solve a complex problem, you have to require very powerful neural network. And the powerful neural networks also decide by the activation also. So if we are using the linear activation, that means your network is not going to solve any more than a linear problem, right? So that will not be solve any complex data. Complex data for any satellite data, you say you look at multispectral, hyperspectral, or the SAR data. All data are very complex data. Those data cannot be solved. Any problem want to do with the linear activation inside the network will not be help us, right? I hope this stopping here because Dr. Jenny will be explaining more detail be in the next class, right? So why do we use neural networks? So we do use neural network because of it is inspiration from the human brain. We can do the analogy artificial brain and the human brain, and the proof of concept that neural architectures can see and hear also, and very effective barriers across a wide range of application. For example, vision, text, speech, medicine, robotics, core is remote sensing, our interest, and also used in widely both in academia and tech industry. We have a powerful software framework, Keras, TensorFlow, PyTorch. Yeah, in the beginning I forget the Keras and TensorFlow was introduced by the that will be Google in 2015, whereas the PyTorch has been introduced by the Facebook R&D groups right now. Both are introduced in the 2015. So as the artificial networks looks like here, so we have input layer, we have output layer, and there are two hidden layers, hidden layer 1, hidden layer 2, 3 nodes, 4 nodes, 4 nodes, and single nodes. So here just two things take away. One is a forward path. Forward path is responsible for giving the that will be current output or estimated output, which is y hat, whereas the backward path is responsible for the network updation parameter. What are the network parameter updation? Bits and the bias of network, right? And artificial is nothing we also always frequently called multi-layer fully connected neural networks. Why multi-layer? Because there are multiple hidden layers in the neural network. So here there are two hidden layers. Likewise, it could be have three hidden layers, four hidden layers. Once the hidden layers more than three, then we call as a deep neural network rather than calling the artificial neural networks, right? So if you zoom one particular nodes, right, you will get looks like here. There's nothing that one node which already we have understood in the previous case, right? So you can understand here y1. Likewise, you can get the y2, y3, y4. Then you can say for s1, s2, s3, s4. Likewise, you will similar. And this is a final y hat, right? So y hat could be a classification task, could be used as sigmoid activation functions, or you can use build any regression task, or if you want to class multi-class classification, then the nodes has been increased at the output layer. So just I'll give you the deeper way understanding. If you want to go, I'll not talk. If you want to understand from the scratch, you have a deep understanding about activation, derivative of activations, loss function derivative, optimization algorithms, and then output layer configuration, how we're going to use depending on the applications. So for me to make you understand all these things require around the 6 to 7 sessions to make you in a mathematical way to be more deeper way. Then moving ahead for the major disadvantage of ANN is called hardware dependence. Sharing is very difficult. Overfitting is normally will happen. Science structure always chosen by the hit and trial method. Solution there is no guarantee. Longer training time and it is not scalable. This is very important point. It is not scalable in the sense that the neural network ANN you cannot not scalable for the images, not scalable for the images videos, because if you are going for this that parameter, like for example, if you go work on the image and data set which are having I would say 16 million images, right? If you want to apply ANN, that will be big task. You will require the even month to train the model. So that is why it's not scalable for the large data set, right? Moving ahead for the deep learning. So I'll give you quick deep learning introductions. So here, if you see the deep learning, so there are what is deep learning? Why do we use deep learning? When to use deep learning? Where deep learning will be used? This will be our focus. Also, how deep learning will be used, not part of this lecture. So as I already told, deep learning is a subset of that machine learning. When we talk about the term deep learning, that means we are referring as a deep artificial neural networks, right? Already told that deep learning is an engineering system always inspired by the structure and the functionality of a human brain. So this is one graph which give you why deep learning is more powerful, right? So here you can see that when the amount of data increasing and vertical axis is nothing the performance of any deep learning model. So you'll see that the performance of the deep learning is much increasing when the amount of data increasing. But whereas the performance of the traditional machine learning algorithm is increasing, but the way the deep learning algorithm the performance is increasing is not increasing the traditional algorithm, right? That's why we need to go for the deep learning architecture rather than using traditional machine learning algorithm. This is one such example of deep neural network. So you can say there are 8 nodes. That means the network is the DNA network is will accept only the data which are having 8 feature only. If you have 10 feature, so you can just use best 8 feature from the data set and you can give as an input over here. And there are 3 hidden layer. Each hidden layer consists of 9 nodes. You can see and the output layer which we have the 4 nodes, right? 4 nodes in the sense that you can do multi-class classification task. That means you can do basically for the crop application, right? Different type of crop, for example, the corn, wheat, and the rice on the say for some other crop, right? Say for right, you can use that, right? So for agriculture application, you can use, you can do medical field for the cancer grading also. You can likewise, you can explore many more applications also. So 4 node, that means for the network giving the probability of the 4 classes, right? Here will be giving and the input data having the 8 features. So if you look at the architecture, you can see that here how complex the DNN architecture looks like, very dense, right? So moving ahead, then we have the first architecture as a seen in LeanNet 5, which is introduced by Lee Kuhn et al. In 1998. This was the original architecture, which are having basically the 2 convolution layer and 3 dense layer, right? So that's why we call as a fully connected layers. So 5 means there are 5 weighted layers. Weighted means the weight associated with the convolution layers and there is a weight associated with the dense layer or which is called fully connected layers. So that's why we call as a 5 weighted layer architectures. So when the author built a model in 1998, that time we were not having powerful that is called softmax activation was not available. Then author did with using the radial basis function. That time the powerful the loss function was not available. Like for example, softmax loss function, right? Cross entropy, which the author did with the maximum likelihood, and the author used 10s activation and the build task and handwritten digit recognitions. But then nowadays, if you want to build from the architecture using any deep learning framework, you can use simplest way because we have a softmax activation functions which you can use output layer. We have a powerful the very good loss functions called softmax loss function or categorical cross entropy, which can be used for handed written digit classification task you can use. So this is architecture if you want LeanNet 5 you can build for the very simple task. And more detail will be discussed by the Dr. Ginny Rajan in the third day workshop. This is Lexington Architecture, which is the breakthrough research in the computer vision field. And then author was uh, when this that in 2012 the model was introduced by Chris SK et al. In 2012. Then the image and data set, which is one of the largest data set, was having 1.2 million images. But recently in 2016, the data set has been increased, having the 14 million images for the image recognition task having the 1000 the the classes in the data set, right? So here we are using say that author use 1000 nodes to classify, to recognize 1000 object in the data set. This was the original architecture as per the author. Here the crash has cured, but you can use this architecture in this one go because that time there was no powerful hardware available. So author was trained with the split mod. So you can see the top and then bottom, and then after training the features were connected and then the prediction was carried out. But nowadays you can do in one go only. So this input image, which were RGB images, color 3 bands. Here you can see, and then goes like this way here, the conclusion, then max pooling, and then conclusion, max pooling, conclusion, set of conclusion, then max pooling, and then flattening operation, and then dense layer, and then finally the soft max layer will be used last layer to give the to 1000 classes of the object, right? I'll not talking more details. I think Dr. Jenny will be discussing that. Then what are the architectures are there? So in the related to deep learning. So this give you slides, give you some idea about what are the tasks, what are the project you can do in the deep remote sensing field where the deep learning has been used also. So segmentation task you can do. There are some architecture listed over here. You can use, you can do cloud detection, you can do dehashing tasks, you can do classification, you can do forest cover, land cover, agriculture crop classification. I mean, what are the tasks is that you can use? So you start from the LeanNet 5, LexNet, VG16, ResNet, DenseNet, InceptionNet you can use. Likewise, segmentation you can do start FCN 8, UNet, SegNet, DeepLab 3, etc. Cloud detections you can use Cloud XNet. This is our model, RSNet, Cloud Segnet, CloudNet, RSNet, Residual Net, etc. can be used. Dehash task you can do for that various model you can use. We also design model, right? AOD net, CSF net, MSR net, RY net, etc. Change detection is very powerful. I mean, for research point of view, all the tasks are important. Change detection is again the task. Unit model, ShyamNITK, triple loss based model, FDCNN, AG, deadnet model. We also introduced the model called this UG, I mean UCDNet. That is that also we have designed the models. And fusion also you can do UNet, autocoder, various model you can do for the fusion of data, panchromatic data, and then this what you call the multispectral data, fusion of SAR data, and then hyperspectral, multispectral, then SAR data. So a lot of the data you can do fusion also. Why do you use deep learning? Because we have advanced algorithm, we have powerful hardware, NVIDIA, Google, Movides, etc. We have a large amount of training data set available in almost many field of engineering and technologies also. And the algorithm deep learning work for the unstructured data. Unstructured data are those data we do not have any ground truth. For example, where the many algorithms which could be used for the unstructured data, right? And this unstructured data is could be any format, right? Which having text, photo, video, audio, web page, etc., blog, etc. And every day, 90% data, about 90% data, unstructured data is generated by human, maybe directly or indirectly. And this unstructured data is increasing 50 to 60% every year. Data is increasing. So if the organization or the company started thinking about unstructured data, then lot more that employment will be generated, lot of revenue will be generated from the unstructured data, right? When to use deep learning? So deep learning you can use whenever you have the data size is large. But if you do not have a large amount of data, of course, you can do some kind of data augmentation so that your performance can be increased also. And also you can use traditional algorithm. But nowadays, nobody using traditional algorithm. Everyone using the deep learning algorithm because they can do in the training the model. There is a called that you can do data augmentation that is called train image generated libraries there, which help us doing the some sort of that data augmentation while the live data augmentation that will also improve the performance of algorithms, right? You need high-end architecture or infrastructure that is called workstation for doing the training of your deep learning model in a less time. If you do not have this, don't worry. You can go free cloud services. For example, that Google Pro, Google Cloud, Google Cloud Computing. You can go for even the Kaggle is also giving very good speed. Also, you can use nowadays Google this Colab is free, is basically slow. In that, you can go for the Kaggle, which is faster than the free. Otherwise, this is a business, right? So they bring it Google this Collab Pro. Collab Pro is much better than this Collab free because it's business. They wanted the money generations, right? So, but if you go for Kaggle, Kaggle is basically free, right? You can do lot many research you can do, lot many projects you can do with the free cloud services also. Even Microsoft Azure also that they are Microsoft also giving the computing you can also explore. And in the deep learning, right? Why? Because how features are extracted, like say for color feature, texture feature, or this morphological features, all features are extracted. You need not to worry. It is basically taken care by the algorithm itself only, right? And as far as performance concerned, the performance of the deep learning is much superior than on the complex problems. For example, classification, NLP, speech, remote sensing data, healthcare, all the application, that performance of the deep learning is much superior than, right? And where deep learning could be used, this is one slide, lot many applications, just few mentioned here: signal processing, image, healthcare, wireless, self-driving, autonomous driving vehicle, robotics, data mining, cyber bus. But our core focus is the remote sensing. So we'll see that in core remote sensing, what are the how deep learning can be used, what are the project has been carried out, that will give you the big picture about the application of the machine learning, deep learning in a remote sensing company. This is what my intention is over here. In the remote sensing, so various tasks which you may be knowing in the image processing, whatever the task you have carried out, maybe traditional algorithm in remote sensing, all those algorithms you can use deep learning also, and some additions also you can do. For example, image classification you can do, image classification, the localization you can do, object detection you can do, and then object segmentation you can do, image contrast enhancement you do, image fusion you can do, denoising, color image colorization you can do, image reconstruction you can do, image super resolution you can do, etc. like that, right? So here color image colorization is very important for basically the SAR data. SAR data for various application whenever you go for the, because SAR is basically that grayscale images, right? So grayscale images you may not able to extract the meaningful information from the SAR data. So, but if you get the, I mean, uh, if you get the make it the colorizations, then you can do lot more. You can extract more meaningful features from the SAR data than very the grayscale images. Likewise, image reconstruction you can do, image supervision you can do, right? So let us discuss. So all the applications, whatever you have seen, is basically is belongs to the one of the basket here. I would say three basket, right? A whole research problem you can put into three basket, right? Which called research problem in a technical word. Simple word basket, right? So you can call regression research problem. You can call the binary classification research problem, or you can call as a multi-class classification research problem. Whatever the research has been conducted or will be conducted, right, around us, whatever is there is belongs to any one big basket here, right? Either could be regression research problem, or it could be a you could be doing the binary regression research problem, or you could be doing the multi-class classification research problem, right? So let us see what are the examples are there which you can explore as a beginner also. So example of the regression problem is, what is regression problem? Very simple word. Regression is a problem where you are going to predict the real value quantity. Real value quantity in the sense that the model should always gives a continuous output. This is what the task right now. So there are various applications are there regression task. I will not touch all the things. Like broadly, I would say any predictions, like say for house selling price is one example, car selling price, right? I mean this, anything you want to predict, right? The price or the weather forecasting, right? Or I mean, you wanted or any recommendation system, movie review rating, tomato, Jota, hotel rating, etc. All you can put it into the regression basket, right? But what are the examples? You can get it many example, but what are the remote sensing application you can do as a regression that is more important for you people, right? So in remote sensing field, what we can do as a regression task, right? Or regression research problem we can solve. Hash removal is one such application. Pan sampling or fusion of multispectral panchromatic data is other example. Weather forecasting, drought forecasting, earthquake forecasting, contrast enhancement, denoising, compression, reconstruction, image super resolutions, all are belongs to the regression research problem. So lot many that research you can conduct as a regression task in the remote sensing also. Some of examples I'll show you may have better understanding. So you can see here, this is called before uh, this. I mean, this is a hazy image, right? So after applying the hazy removal, right? So you can see here that the input image, which is there is a hazy image. So once you do some sort of hazy removal by apply algorithm, right side you can see the algorithm where we have applied. I mean the that has removed algorithm. The picture is much better than the input image because this that satellite data contaminated a lot of hazy image, right? So right side is like say for a hazy removed image, so the quality of image is much better than the input image, so that lot many that the feature extraction and other tasks can be done with the help of uh, the different algorithm. The deep learning could be also used. So we have also done the work which called the hazing of deep example of dehazing of remote sensing data. So this our people already published this year only. So we work on the say for first synthetic data, and then if you look at the ground truth, so first row is the basically are the ground truth. The second row is basically that called the here the hazy images you can see synthetic data, and the C row or the third row is basically called output of EODB algorithm. And then next row is basically the output of D, which is called MSR, that algorithm output. And then this E, which is the grayscale image output, C RY output. And the last is the output of the deep learning model, which we have designed that, right? So this model also we have that experimented on the satellite data. The images was captured from the Bangalore region district. So you can say these are input images, real satellite data, and then that the second row is basically that output of our deep learning algorithms, and third is the that output of the called MSR algorithm. So MSR algorithm is the that which we have basically our focus was this was the most recent. So we were improve this algorithm. So our comparison for real data, real satellite image only on this algorithm, right? So this paper was published already. You can visit my web page and get the more detail about this. Then this talk about an example of the fusion of multispectral and panchromatic images. So this is a ground truth. This is a pan input image. So panchromatic data, that satellite data, contain basically the rich that is spatial information, whereas the lower resolution image basically multispectral data which contain rich spectral information. So both images are not useful for doing any kind of real task, any application. But if you do fuse it, this data is fused on this data. Well, I mean multispectral data. So the fuse or the pan-stopped, the multispectral image that have I mean the rich spectral information and also rich spatial information, so that then you can extract lot more feature from the fuse data, and this data you can give it to the any algorithm. So whatever the data actually you will get from the NRSC ISRO for your project, that is basically some sort of the pre-process data you get it. There will be any all kind of noising will be denoising done, all kind of the registration will be done. And if you wanted like some better resolutions, right, better images, so some sort of they will give you do the pans of evening also, then they'll give you the fuse image, right, better data. Because when the contour set data capture the satellite image, so always will be capturing the multispectral data and also the panchromatic data. So once you want to data, so you can ask both like panchromatic data and the multispectral, and then you can fuse also, and you can do some sort of research also. You can do denoising. So denoising here, the first column is the ground truth, second column is the noisy images, third is that authors, not ours. So this is a link here. And then last two columns are basically the traditional algorithm. This was done, I would say, in 2013, right? So when author did work on this denoising, that time there was no any the deep learning model was available for comparison. So author did comparison with the traditional method and demonstrated that the deep learning based here image prior algorithm is, which is deep learning based algorithm, is much superior than the non deep learning algorithms. You can also do use for comparison. This is just illustrative example for non-remote sensing data, but you can do for the that hyperspectral data where that you can do DH. I mean, this comparison is very essential because it's very high volume data. Then you can go for the next application is a binary classification task. So second, as a the second the research problem which we call binary classification. So binary classification research problem is a problem where we are going to classify the object is belong to one of the class, right? For example, cat and dog already we have seen that examples. So here is the scatter plot of data. You can see that the blue color data is belongs to the zero class. Yellow class data is belongs to the class one, right? So it's very simple task. You can do binary classification task. And what lot more you can do in remote sensing, right? Remote sensing, you can do a lot of application, right? Just I'll explore. Remote sensing you can do as a binary classification binary search problem. You can do road extraction as a segmentation task. You can do building extraction. You can do river network extractions. You can do even rail network extractions. You can do cloud segmentation. You can do change detection. You can do landslide detections and many more, right? You can explore. So all those things which could be part of research where you can do, I mean, kind of the simple task, right? You can do from the satellite data, from the multispectral data, from the aerial data, from the UV data, right? Whatever data you have, you can do that, right? This is some examples. So here this is we did it started the first our paper was published in 2019 for that this called road that object segmentation on Massachusetts road data set available over here. And this you can say input aerial image, then ground truth, this our model with compare with the set of the benchmark algorithms. Likewise, you can do for building as an object segmentation. You can do input images again same for Massachusetts building data set, this ground truth. And then these are the different algorithm. This was the best algorithm by the author, which was published in 2018. So, but this you can see that the author used some sort of on this top of this, the model predicted author used the CRF. CRF stands for conditional random field here, which is basically complex method and it is normally used as a post-processing method. There are two kind of the post-processing method you can do. I mean, you can use CRF or you can use a morphological that concept you can use. Mathematical morphology concept you can use. For example, dilation, erosion, opening, closing. These are the popular method which normally used as a post-processing method, right? Then uh, you can do for the cloud segmentation, cloud detections. So this is our work. You can say these are the ground truth, and these are the predicted images from our algorithm. We work on the Landsat 8 images, and then these are the comparison with just for illustration, just RSNet1 model. Detailed comparison, all the people you can refer in our paper, which was published in 2020. Then you can do also the change directions. So these are the change directions. We require the bitemporal images, which we call time T1, T2, which could be like, say, for example, 2000, say for 15 and next images was captured in 2000, say for 20. So 2015 to 20, what are the changes happen? Maybe building changes or some building or the roads, new roads has come. So you can see for build change section, road change sections, right? All the things can be done. This is, you can see there are four different data set. This having the only row, I mean this, that data set one, data set two, data set three, data set four. So this is only building mentioned here. This is building and some other also mentioned here. This also having the building here, and this having the more than multiple objects you can see, right? Building, roads, a greenery, some swimming pool, etc. also mentioned over here, right? So this work also is accepted, minor revision. You can do even this landslide detections from the satellite data. So you can see that here that we have the first column, which are the input raw images, satellite data with the landslide is marked. Second column, if you see that the landslide predicted by the unit model, and the third column, if you see that landslide predicted by the residual unit architecture, right? So as a segmentation task used for predicting the landslide detections, right? So red color indicates the false negative, and yellow colors indicates the true positive, and blue colors indicates the false positive, right? So this paper was published in 2020, year 2020. You can see downloaded freely available paper. As far as multi-class classification is concerned, so multi-class classification, you can do the task like say for this a simple scatter plot of data. So here you can say the yellow, green, blue color belongs to the that zero class, and yellow color belongs to the one class, and green class data belongs to the third class, right? So three class classifying you can understand. Likewise, there are many examples application where deep learning could be used. So here just highlighted only red color will be more important for you people. Let us see what are the examples you can explore as a object segmentation, as a multi-class semantic segmentation. So this is the one that popular data set called CAMID data set, which you can do called multi-class semantic segmentation, which are having 11 class. So first row is a test sample, second row is basically ground truth, third is the predicted output from the by the model, which we call Segnet. Segnet is a one such model is most popular model for the doing a multi-class semantic segmentation. Initially, the Segnet was published in CBPR 2016. Later on, it was work was extended and published in the PAMI transaction in 2017. This is a data link data set available. You can download, which you can interested. You can explore the work. The extended work was which was in also that bigger data set called Sun RGB dataset, which are having 13 classes than the 11 classes. This dataset is also available publicly. You can explore over here. And first row is same test samples, ground truth, second row, third is our the segment printed model, right? We also did the work on this line, the multi-class semantic segmentation. So once we did road segmentation, then we did road building and then background detection. So these are the test aerial images. These are the ground truth, and these are the our model, which we called design called O-segment model. The model was published in year 2021. So you can visit my profile and you can download and you can explore that, right? We also published this year two transactions paper. I mean this letter to this year. One is called land cover segmentation. So this our paper already published in this year 2022. That DPNet model we designed for two data set. We work on that. One called the land cover data set and then other called WSDL data set. So here you can say test images, proposed model, and then ground truth. You can see that these are four classes, right? Building, woodland, dust, and the water. So easily able to, you can see over here. And then we want WSDL data set, which are having basically the six classes, test images, ground truth, and our proposed model. You can see that. We also work on the multispectral and the hyperspectral data set. So on this various, this our paper published in 2021. Also work on hyperspectral data set, which are having around 100 bands. So on this University of Pavia data set, which are having 115 bands, whereas the that Indian Pines dataset, which are having 220 bands. So these are the input image, these are ground truth. This is the place exactly I visited in 2018 as a visiting professor there, University of Pavia. I have seen this, and this was dataset was released by the Paulo Gama, who is a professor in the University of Pavia. I also met with him, right, who has created this dataset. And this dataset also having more classes, 16 classes, this having the 9 classes on hyperspectral data. So other also you can do in multi-class this segmentation, which we call more specific instant segmentation. You can see on COCO data set that different data object object segmentation task. You can see over here that a lot of the examples are listed over here. You can explore this and you can read more about the instant segmentation, how could be used as a multi-class semantic segmentation task. So as coming to the open source remote sensing data set for deep learning. So as I told you, there are 3 tasks: regression task, many classification task, and multi-class classification task. These are the data set which are available. You can explore. Image dehashing, Kaggle data set you can visit. Denoising, you can visit this. You can learn, you can work predicting a dot using weather and soil. You can visit over here. Predicting the earthquake using Turkey data set, you can use this, and Indian subcontinentals is also available you can do. And for binary classification segmentation task for single object, you can do already I told you, right? Building segmentation, and then Massachusetts road and building data set available, arena data set is available, and the CBPR deep globe data set is available, cloud segmented the data set available, like say for 38 cloud, 95 cloud, you can work on those. Then as a multi-class classification and segmentation you can do like this is a data set which was released in 2017, learning aerial image segmented from online map. 3 class segmentation you can do. Likewise you can do more than 3 land cover data set which are released in 2020. You can also work on this. Likewise, there are other common data set for doing multi-class semantic segmentation. You can Pascal VOC data set, and then Cambridge data set. I told you CitySCAP data set, BDD 1000K data set, Maply data set, Polo data set, right? All those data set could be used for multi-class semantic segmentation. As annotation tools, there are 2 tools last year that is called Label RSS. You can use this for doing annotations, or you can use for labeling also for doing this, right? But for some time, this will be working. Sometime we have to use different approach for doing annotations from with the label of vector data set, and then this that will be uh, other data set available. So now, giving the just remote sensing what a research we have conducted in ITK. So this is my team as me. I am the leader at NITK. PhD research scholar we have 2 working. One more joining here, that Sarabhya, which is currently working on as a project staff GRF. She is joining the next month as a PhD scholar. And this is a MTech who work on the project change section, and he now 3 more are joining this year as a on the remote sensing domain. This one project who work on this that called panning sharpening or this data fusion. They work on this, and other batches will be joining this year, and 2 research center working in this domain also. I am working very closely with ISRO as well as some foreign collaborators like Indian scientists as ISRO, Sudhakar Reddy, Chintara Sudhakar Reddy. I'm working with him since 2017, and Nalli Madam, I'm working since 2000, I would say 20, and Dr. PG Divakar also working since 20, and there are few that foreign academician I'm closely working. Professor Fabio is my, close this collaborator, and also work with Targay Selik, Chenchan, and Mustafa. These only limited I work with the foreign in remote sensing domain. This is a project which I'm already this is completed. This about completion ISRO project. This is ongoing from the ISRO project, and these are my research area which I work with basically, right? Aerial and satellite data, remote sensing, hyperspectral radar remote sensing as well. And we have published very 21 good quality journal paper in the remote sensing paper. These are the that glimpses research what you have seen already. Just I'm flashing for your info, right? my team has done work. This is very interesting. I told now use CDNet. We have designed the transaction right publish 22. We work dedicated on the change sections from the bitemporal sentinel to multispectral data. And this paper was published already available. These are ground truth and these are a model. And this is the recent comparison. You can see that, right? You can explore. We also work on last year on this hyperspectral classification. This paper was published. You can explore the numerical results. We on this this a de-hazing task. We have our paper was published 2022. You can explore in multimedia and tools and applications, right? This also fusion, we worked it, our result in our hand. We will soon writing the on the fusion of the this multispectral and pan farming data. We want to just write the paper on our Cartoset data set. We are working on this. And this is some the quite quality publication which we did with my team, right? During last couple of years. So you just for your info, right? If you want, you can follow it. Total 21 publication, 22. One more you need to be updated, not there. And D has is not mentioned over here. Yeah, that's all about my work.